Hello aspirant, this question is from GATE 2021, Mechanical Engineering paper, set 1, question number 25. Consider a single degree of freedom system comprising a mass m supported on a spring and dashpot as shown in the figure. If the amplitude of free vibration response reduces from 8 mm to 1.5 mm in 3 cycles, the damping ratio of the system is dash. So the amplitude at first is 8 mm and then after 3 cycles of vibrations, it has reduced to 1.5 mm. There is a decay of motion happening, and so we will use the logarithmic decrement to find out the damping ratio of the system. So if this is the time axis and this is the amplitude with respect to time, we see that the maximum amplitude goes on decreasing in every cycle. The condition that we are being given here is if this maximum amplitude is 8 mm, let's say this is x1 after 3 cycles, that means maximum to maximum 1 cycle, then second and then third cycle. Let's say this is x1, this is x2, x3, x4. After 3 cycles we have the amplitude to be x4. This amplitude, this maximum amplitude is 1.5 mm. So it has reduced from 8 mm to 1.5 mm. So we have the logarithmic decrement as delta is equal to natural log of the successive maximum amplitudes. That means it is x1 upon x2. This ratio x1 by x2 should be greater than 1. So it is the larger amplitude x1 by smaller amplitude x2, so that this ratio is greater than 1 and we get a positive value of natural log. But this is for a single cycle. For m cycles, we have delta is equal to 1 by m ln of x1 upon xm plus 1. This is for m cycles. So substituting for m equal to 3, we know our number of cycles in which the decay has taken place is 3 cycles, and as we know x1 is given to be 8, x4, that is m plus 1, 3 plus 1 is x4 in our case, and it is given to be 1.5 mm, x1 is 8 mm. So just substituting all of these values, we get the value of delta to be 0.5579. Now by definition of the amplitude x, we have delta is equal to zeta omega n Td. So for free damped vibrations, we have logarithmic decay delta is equal to zeta, which is damping ratio, omega n is natural frequency of the system, and Td is nothing but damped period. So if we just substitute zeta omega n, Td as 2 pi omega d, and then omega d as omega n under root 1 minus zeta square. So we have omega n is giving 1. It is 2 pi zeta by under root 1 minus zeta square. So the only unknown in this is zeta now, because we have already calculated logarithmic decay here. Putting this value here, and in the exam it will be difficult to find out zeta if we take the complete term. So what we can do is, as damping ratio zeta is very less than 1, we can say that 1 minus zeta square is approximately equal to 1. Hence, root over 1 minus zeta square is also almost equal to 1. And therefore, we have, putting this, delta, that is logarithmic decrement, is 2 pi zeta. Putting the value of delta from here, 0.5579, zeta as 0.5579 divided by 2 pi, which is calculated to be 0.0888. We want the answer to be rounded off till 3 decimal places, so the answer is 0.089. 0.089. Damping ratio, of course, it is unitless because it is the ratio of damping constant for the given condition divided by the critical damping constant of that system. To learn about the derivation of logarithmic decrement formula, you can refer to NPTEL video Module 2 Lecture 7 L7 Decay of Motion from the course Soil Dynamics by Dr. Dipankar Chaudhary, Department of Civil Engineering, IIT Bombay. I hope you understood the solution. Thank you.